All right, we're working in our Grosch's book, Developmental Math 2, and this video we're going to talk about Section 4.3, Scientific Notation. All right, up here at the top of the page, you see the big question, why do we use scientific notation? Scientists often deal with extremely large and extremely small numbers. For example, the distance from the Earth to the Sun is 150 million kilometers, or 93,750,000 miles. Another example is the diameter of the influenza virus, which is this really small decimal here. The idea behind scientific notation, and you may or may not have seen it in some of your science courses, is that it's a convenient way for us to write very large and very small numbers without having all the zeros or all the digits for our eyes to try and track. So we're going to talk about converting back and forth from standard form of a number, which is just the number all written out with all of its digits, to scientific notation form of a number. All right, so there's a few rules that we have to remember when we're working with scientific notation, and that's that scientific notation has two parts. It has a number part, a decimal number part, and then it has a power of 10. The decimal number part, which is the first part right here, has to be a number between 1 and 10. So we'll manipulate that number by moving the decimal to the left or right to make it a number between 1 and 10. The power of 10 has an exponent that's either a positive exponent or a negative exponent. You can see a negative exponent here. I just have an easy way to remember this. You may have your own way if you've used some scientific notation already. I'm just going to tell you my easy way to remember this. If the exponent is positive, the number is big. It's a big number. More than 1,000, more than 10,000, more than 1,000,000. If the exponent is negative, the number is small. So it's a decimal. So positive exponents for big numbers, negative exponents for small decimal numbers. And you can see this if you're looking at these examples here. You can see this has a positive 6 exponent on it. This is a big number, 2.5 million. This is a negative exponent, and this is a small decimal number. So that's how I remember it. And here you can see the scientific notation here. This one has a positive exponent on it, and you can see its corresponding big number. Also notice that this negative here in front of the number doesn't do anything really. It doesn't affect the decimal. It doesn't affect the exponent. It just carries over from here to here without really doing anything. There's some explanation down here about converting from scientific notation to standard notation. So let's just look at this a little bit here. To convert 1.95 times 10 to the negative 7 to standard notation, you start at the decimal point. All right, the negative 7 exponent here means this is a small decimal number. So if you know that, then you know that to make this a small decimal number, we will have to move the decimal to the left. So I'll usually draw an arrow like that. And I'll start with 1.95, and my decimal right here, I'm going to move it 7 places. 1, 2, 3, 4, 5, 6, 7. Well, there's a lot of lumps there and no numbers, so all of these will have to be filled in with zeros. And you need this 0 here in the ones place. So we moved it from here, 1, 2, 3, 4, 5, 6, 7 places, and now the decimal is here, and that results in this decimal number right here. So let's look at this example. To convert this decimal number to scientific notation, you first move the decimal. So this is where sometimes it can get tricky and students can get confused. You need to decide where you're moving it first. And remember up here, I told you that there's a rule about how this number has to look. This number has to be between 1 and 10. So when you move your decimal, you're going to want a non-zero digit in the ones place and then the decimal. So we only have one digit and then the decimal. So when we look down here, we're going to move this decimal all the way down this way, and we're going to put it after the first, to the right of the first non-zero digit. So it needs to go there between the 1 and the 9 to make this a number between 1 and 10. So you're going to move the decimal always when you're doing this. When you're putting a number in scientific notation, the decimal goes after the first non-zero digit, to the right of the first non-zero digit. And this is going to be times some power of 10. We know, since this is a decimal number, this is the number, this should be a negative exponent. And how many places did we move the decimal? We moved it 1, 2, 3, 4, 5, 6, 7 places. So there we go, 1.95 times 10 to the negative 7. So let's look at the examples on the next page. And we're going to practice converting to scientific notation. You can write on this line right here. I find it more convenient to write down here just because of the way I'm recording this. It just fits better on the page that way. It doesn't matter where you write. It's your workbook. Okay, so we're going to convert this to scientific notation. Right now, the decimal is right here. So we need to make this a number between 1 and 10. So this decimal has to go all the way down here, but where should it go? We always put it to the right of the first digit that's not 0. So it needs to go here between the 3 and the 6. So this will convert to 3.65. Then we're going to multiply times some power of 10. Now we have to decide whether this exponent should be positive or negative. This is a big number, so this should be a positive exponent. How many places did we move the decimal? Looks like 9, so this exponent is going to be 9. There's a decimal here. All right, let's look at this one. Same thing. We need to move this decimal so that it's right to the right of the first digit that's not 0. So it needs to be between the 9 and the 3. So this is going to become 9.3 times some power of 10. This is a small decimal number, so this exponent needs to be negative. How many places did we move that decimal? We moved it 3 places. So it's 9.3 times 10 to the negative 3. Okay. This negative sign right here is not going to do anything. Just carry it straight down. It's just going to be right in front of your first number. That's all it's going to do. All right, this decimal needs to move. It needs to be to the right of the first digit that's not 0. So it's really going to be to the right of this 4 right here. You could write this as negative 4. It's perfectly fine. Usually in science, we'll put the decimal in, just say negative 4.0 times 10. Is this a positive exponent or a negative exponent? This is a decimal number, so this should be a negative exponent. How many places did we move that decimal? Looks like 9 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Negative 4.0 times 10 to the negative 9. All right, number 4, we're going to go the other way, and we're going to start with scientific notation, and we're going to convert it to standard notation. So the first thing you want to look at is this exponent. This is a positive exponent, so this should be a big number. To make this a big number, we're going to move the decimal to the right. How many places are we going to move it? This tells us how many places to move it, so we need to move 4 places. Around the 5 and the 6 counts as the first 2 places. So this is around 1, 2, 3, 4, and then we can go back and put a comma in. We get 45,600. On number 5, the exponent is negative, so this is telling us this is a small number, a decimal number, so the decimal is now going to go to the left. It's going to go to the left 5 places. Around the 1 counts as the first place. So that would be 1, 2, 3, 4, 5, decimal, and you need that 0 in the 1's position for standard notation. So we move the decimal 5 places. 1, 2, 3, 4, 5, but we keep this 0 as a placeholder for the 1's position. Okay, here we have a negative in front of our 5. It's not going to really do anything. Just carry it straight down. This exponent's telling me we're going to make a small decimal out of this because it's a negative exponent. So then the exponent needs to go this way to the left to make this a small decimal number. Right now, this is a whole number and the decimal is here, just to the right of the 5. So if I carry the decimal around, that counts as one place. And then I need to carry it around another place. That would be my 2 places. And there's my decimal and my 0 as a placeholder.